Hello everyone, welcome to Vedantu Malayalam channel. How are you guys doing? And welcome back once again to continuity and differentiability, that is chapter number 5 of plus 2. Well, today is going to be the last lecture of this chapter where we will be completing the chapter with our last topic, parametric form and second order derivatives. Now trust me, be it CBSE board exam or Kerala board exam, this topic is definitely going to come in your exam. That is guaranteed, because some 4 marks, 5 marks questions can definitely be formed from this topic. So let's make it super duper easy for you. Now, as you guys know that this is one of the lengthiest chapter, hence we completed it in basically 4 lectures, so that your understanding of every topic is in depth. And yeah, so which topics have we already completed? So we have till now learnt about limits, continuity, differentiability, composite functions, chain rule, product rule, quotient rule, inverse trigonometric functions, exponential and logarithmic function, logarithmic differentiation. So till now we have already completed all these topics. If you have not yet seen them, go watch lecture 1, 2, 3. Today we are going to learn these two topics in lecture number 4, that is how to find out derivatives of functions which are in parametric form and how to find out second order derivatives. Alright, so without wasting any time, let's get quickly started. If you are new on the channel, don't forget to subscribe and do share this video with your friends too, so that they also get benefit by learning physics, chemistry, maths and biology of plus 2. Alright, so what is parametric form and how is it used for finding derivatives of functions? Well, if you have two variables x and y, and we see that variable x is basically a function of t and variable y is also a function of t, then such a relationship is called as parametric form, where t is called as the parameter. For example, very good Samuel, x is a function of t, so let it be 2t square. Y is a function of t, so let it be sine t. Okay, so what we see here, x is also written in terms of t, y is also written in terms of t, right? Similarly, can we have more example? Yes, they both can be trigonometric function. For example, x is cos 2t, y is sine square t, something like this. Or is it necessary that they should be a function of t only? No, the parameter can be anything. The parameter can be anything. For example, x can be written as let's say cos 2 theta, and y is also sine square theta. So here also our theta is the parameter and x and y both are dependent on them. Alright. Now what if we need to find out derivatives of the function y with respect to x? How can we do that? Y function is not related to x. So how can we find derivative of y function with respect to in x variable? Well, for that, first of all, what we will do, we will find derivative of y with respect to t. It is basically f dash of t, right? The derivative of ft. Similarly, we will find derivative of x with respect to t. It will be g dash of t, right? Now just divide this by this. So dy by dt is divided by dx by dt. So we will basically get f dash of t upon g dash of t. Now dt dt cancel. This implies that dy by dx is nothing but f dash of t upon g dash of t. So now you understood how we will find out derivative of y function with respect to x function when both are written in terms of some other variable. Let it be t, theta, anything. Okay, got it? Alright, let's do one quick question from NCERT. If x is a cos theta, y is a sin theta, find dy by dx. Very simple. Dy by d theta is differentiation of a sin theta. What is the differentiation of a sin theta? A is a constant. Sin theta differentiation is cos theta. Similarly, dx by d theta is what? D by d theta of a cos theta. What is differentiation of cos theta? Minus sin theta. So it will be minus a sin theta. Now you simply find out what is dy by dx. dy by dx will be a cos theta divided by minus a sin theta. A cancel, we have minus cot theta. Clear to all of you? How we have to find derivative of a function if it is written in terms of some other variable. Clear? Give me a thumbs up quickly if it is clear. Okay. Now we will do more questions of parametric forms. Before that, let's learn about second order derivatives as well, because sometimes they are related also. The question can be combinedly asked sometimes. Okay. So now let's learn about second order derivatives. Now, why do we need to find out second order derivative? Have you ever thought? Now, why do we find out derivatives first of all? So, what is a derivative? A derivative tells us basically instant value. For example, what is velocity? Velocity is instant displacement with respect to time, isn't it? What is velocity? Velocity is the difference in the displacement, in the distance with respect to time, right? Now similarly, what will be acceleration? Acceleration is basically instantaneous velocity, change in the velocity. That means d by dt of ds by dt. So that means I am double differentiating the displacement with respect to time. And this will give me d square s by dt square, which is called as second order derivative. So what is a second order derivative? So if you differentiate a variable first, so it is first order derivative. So dy by dx is called as first order derivative, right? Similarly, if you differentiate it again, it will become d square y by dx square, and it is basically second order derivative. Everybody clear? What is a second order derivative? If you differentiate the first order derivative, you get second. If you differentiate it, third order derivative. Again, you differentiate it, fourth order derivative. Like that, so on. But in our syllabus, we are only going to learn about second order derivatives. Okay. So suppose y is a function of x. So dy by dx is f dash of x. Now d by dx of dy by dx will be f double dash of x, differentiating it two times, and this is basically d square y by dx square is nothing but differentiate your function two times. This can also be written as d by dx of f dash of x. For example, suppose y is a function of x. So dy by dx is sin x differentiation cos x, right? D square y by dx square will be cos x differentiation. Again you differentiate it. So d square y by dx square will be minus sin x. So like this we get the second order derivative. Very good, Samuel. Absolutely right. Understood what is second order derivative? How we find it? So easy, right? Now, this topic definitely comes in your board exam for 4 marks and 5 marks, but the questions are very easy because you just have to differentiate it again. No other concept, no extra logic. Just keep on differentiating, that's it. Okay. Now, here is a very, very easy example to start with. Of course, we will do advanced problems also. Now, if y square is 4x, what is d square y by dx square? That means differentiate it. So, differentiation of y square is differentiation of 4x. Y square differentiation is 2y into dy by dx, right? 4x differentiation is 4. So, dy by dx is 4 by 2y. 2 2s are 4, so it is basically 2 upon y. Can also be written as 2 into y to the power minus 1. This is dy by dx. Now we have to find out the second order derivative. So d square y by dx square will be differentiation of dy by dx. When you differentiate this, you get this, right? First order derivative when differentiated gives us second order derivative. Now what is differentiation of y to the power minus 1? It will be minus 2 upon y square. What is the differentiation of 1 by x? Minus 1 by x square, right? So d square y by dx square is minus 2 by y square. Now what is y square? Y square is 4x. So d square y by dx square is minus 2 upon 4x. This is my answer. Understood? That's your answer. Easy, right? Simply we have to do double differentiation. Okay, now these are the two topics which we had to learn today. Now, if you have understood everything till now, quickly solve this homework question and comment the answer. I will see who is answering it correctly and the fastest. Alright, now let's practice lots of questions from these two topics so that your understanding is perfect and you have no doubt left. Alright, so solve it along with me and keep commenting the answers if you solve it before me. Okay, question number 1. X and y are connected parametrically by the equation x is 4t, y is 4 by t. Without eliminating the parameter, find dy by dx. Very simple. Y is 4 upon t. So dy by dt is differentiation of 4 upon t. What is the differentiation of 4 upon t? Just now we have seen differentiation of 1 by x is minus 1 by x square. So this will be minus 4 by t square. Similarly, x is 4t. Differentiation of x with respect to t is differentiation of 4t. What is differentiation of 4t? It's just 4. So dx by dt is nothing but 4. Now we will find out dy by dx. So dy by dx is dy by dt divided by dx by dt. So dy by dt is minus 4 upon t square divided by 4. What will we get? What should be the answer? Minus 4 upon t square divided by 4 is how much? Tell me quickly. Minus 4 upon t square divided by 4 is? Tell me. Minus 1 upon t square. That's your answer. So dy by dx is simply minus 1 upon t. No, we are not multiplying. We are dividing. So 4 cancel. Minus 1 upon t square. That's your answer. Okay. Understood? Moving on. If y is tan inverse x whole square, show that this plus this is equal to 2. Now here we need to understand what is y2 and y1. What do we understand by y2 and y1? y2 is nothing but d square y by dx square. Okay. y1 is nothing but dy by dx. Clear? What is y2? d square y by dx square. What is y1? dy by dx. First order derivative and the second order derivative. Okay. So we have to prove that this equation is equal to 2. For this, what we need to know? We need to find out what is dy by dx and what is d square y by dx square. So we need to find out the derivatives. So first of all, if y is tan inverse x whole square, then dy by dx, or let me simply write it as y1. y1 will be differentiation of tan inverse x whole square. What is the differentiation of tan inverse x whole square? It is 2 times of tan inverse x into differentiation of tan inverse x. So y1 is 2 times of tan inverse x into 1 upon 1 plus x square. Clear to everybody? This is our first order derivative. Let us now find out the second order derivative. Second order derivative will be differentiation of first order derivative. That means differentiation of 2 times of tan inverse x upon 1 plus x square, right? mm, yeah. Okay, so there is one other way of doing it. What is that? Let me write it this way. So from this equation, can I write 1 plus x square into y1 is 2 times of tan inverse x. Can I write it like this? Yes. So now I will simply differentiate this function. So what I am going to do, I am going to differentiate the left hand side, that is 1 plus x square into y1. Differentiate this, and I am going to differentiate the right hand side, that is 2 times of tan inverse x. Let's see what we get. We will apply product rule. This is function 1, function 2, product rule. So when you apply product rule, it will be differentiation of 1 plus x square into y1 plus differentiation of y1 into 1 plus x square is equal to differentiation of tan inverse x, 1 upon 1 plus x square. So 2 upon 1 plus x square. Simplify this. What is 1 plus x square differentiation? When you differentiate this, you get 2x into y1 plus y1 differentiation is y2, right? If you differentiate the first order derivative, you get second order derivative. So it is y2 into 1 plus x square is equal to 2 upon 1 plus x square. Now simply bring this to the left hand side. What do we get? We get we get 2x into x square plus 1 into y1 plus y2 into 1 plus x square whole square is equal to 2. Now just check. This is what we needed. Hence proved. Hence proved. How simple is the answer? See, x square plus 1 whole square y2, x square plus 1 whole square y2, 2x x square plus 1 y1, 2x x square plus 1 y1 is equal to 2 is equal to 2. We have got what we required. Clear? Okay. So that's our final answer. Oh, we had more space. So should I mention it? Anyways, you guys understood, right? Next question. Find the second order derivative of the function e to the power 6x cos x. They are asking about second order derivative. So first of all, we will find out the first order derivative. Let y is equal to e to the power 6x cos 3x. Now dy by dx is differentiation of e to the power 6x into cos 3x. We will apply product rule, first function into second function. How we differentiate it? Differentiate first function multiply with second function plus differentiate second function multiply it with first function, right? E to the power 6x differentiation is e to the power 6x into 6 into cos 3x plus cos 3x differentiation is minus sin 3x into 3 into e to the power 6x. This is dy by dx. Now, can we take out anything as common? So, e to the power 6x can be taken out as common. So, dy by dx is e to the power 6x into 6 times of cos 3x plus it will be minus 3 times of sin 3x. This is what we are getting again. Now we have to differentiate it again. This is the first order derivative. We will differentiate it again. So d square y by dx square is differentiate these two functions again. Now which rule? Product rule. First function into second function. Product rule will be applied. Differentiate e to the power 6x. Yeah. Differentiate e to the power 6x multiply with second function cos 3x minus 3 sin 3x plus differentiate the second function. Differentiate 6 times of cos 3x minus 3 sin 3x multiply with e to the power 6x. Now quickly let's differentiate. E to the power 6x differentiation is 6 times of e to the power 6x and we can directly, okay, leave it. We'll open the bracket later on. Cos 3x minus 3 sin 3x plus cos 3x differentiation is 6 into 3 into minus sin 3x minus 3 into 3. Where should I write? I will write it here, okay. 3 into 3 into cos 3x whole into e to the power 6x whole into e to the power 6x, okay. So when I open the bracket, what do I get? I get 6 6 is 36 cos 3x and 6 3 is 18 sin 3x plus 6 3 is again a minus. Yeah, minus 18 sin 3x and minus 3 3 is 9 cos 3x. Oh my god, whole multiplied with e to the power 6x. So finally our sign is coming correct or not? Cos 3x and minus sin 3x, correct. And we have when we differentiate this, cos 3x becomes minus sin 3x, minus sin 3x becomes minus cos 3x, correct. Now 36 minus 9 is 27. So we get 27 cos 3x minus 18 to the 36. 36 sin 3x whole multiplied by e to the power 6x. This is my answer. Very, very lengthy problem, and that's the solution for it. Alright, so basically what you have to do, first you have to find out the first order derivative, then you differentiate it again to find out the second order derivative. That's it. That's like very simple procedure. It can be lengthy, but the concept remains same. The basic understanding remains same. Okay. One more question based on second order derivative. What you have to do here, y is a function given in terms of e to the power mx plus b into e to the power nx. Show that say d square y by dx square minus m plus n dy by dx plus m and y is equal to 0. For showing this, first you find out what is this, what is this. First we have to calculate that. So if y is this, dy by dx is d by dx, differentiate a into e to the power mx plus differentiate b into e to the power nx. What do you get? We get a into m into e to the power mx plus b into n into e to the power nx. This is dy by dx. Now you double differentiate it. You differentiate it again. What do you get? D square y by dx square will be differentiation of a m e to the power mx plus differentiation of bn e to the power nx. So mark it as equation number 1. Now e to the power mx differentiation is again d square y by dx square is a into m square into e to the power mx plus b into n square into e to the power nx. So this is d square y by dx square. Now let's look at this equation. This is equation number 2. Now let's take the left hand side and see what we get as the answer. Okay. Here we have space. So we will take left hand side d square y by dx square minus of m plus n dy by dx plus m into n into y. What we get? What is d square y by dx square? A into m square into e to the power mx plus b into n square into e to the power nx minus m plus n into, what is dy by dx? dy by dx is this, a m e to the power mx b n e to the power nx plus m into n into a into e to the power mx plus b into e to the power nx. Now open the bracket and multiply everything. What do you get? So basically when you multiply, you will get a m square e to the power mx b n square e to the power nx. See, m into m square, so minus a m square e to the power mx. M into n will be mn minus a m n e to the power mx. Similarly, bn multiply with mn will be what? Minus bn square e to the power nx minus bn e to the power nx. No, bmn, sorry. bmn e to the power nx. And lastly, we will open this bracket. A into mn, b into mn. So you have a into mn into e to the power mx plus b into mn into e to the power nx. Now you check anything getting cancelled. Well, yes, everything is getting cancelled. Am square minus am square, bn square minus bn square, minus AMN plus AMN minus BMN plus BMN equals to 0, equals to right hand side. Hence proved. So simply what we have to do, first we have to find out dy by dx, then we have to find out d square y by dx, then we will put everything in this formula on the left hand side, है ना? Write it here, taking left hand side, we have proved it equal to the right hand side, hence proved that this statement is true. This type of question will definitely come in your board exam for 5 marks. So practice it. It's very easy if you practice. Okay? If you don't practice, obviously it will be very difficult for you. Alright, now let's solve some questions which have been asked in the previous year question papers. Just few questions, quickly we will do, okay? If y is root over ax plus b, prove that y into d square y by dx square plus dy by dx whole square is equal to 0. Quickly, let's solve it. Y is given this. What is dy by dx? Differentiation of root over ax plus b. It is equal to 1 upon 2 root over ax plus b. है ना? Root x differentiation is 1 by 2 root x. Okay, but yeah, once you differentiate ax, you will get a also. So dy by dx is this. Okay, now what will be d square y by dx square? Double differentiation. So differentiate again a by 2 root ax plus b. Differentiate it again. So when we differentiate it again, what do we get? Differentiation of numerator upon denominator. How do we do that? D square y by dx square is equal to differentiation of numerator into denominator minus differentiation of denominator into numerator divided by denominator whole square, right? Now simplify this. What do you get? So we get d square y by dx square is, a differentiation is 0. So this whole term becomes 0 minus differentiation of root x is again 1 by 2 root x. So 2 divided by 2 ax plus b into a square, right? Whole divided by ax plus b, because root over ax plus b whole square is ax plus b. Now we will check whether we are getting this equal to 0 or not. So for checking this, I don't have space, so I'll do it here. Y into d square y by dx square, is it happening? Let's see. 2 cancel and we have a by 2 root ax plus b, a by 2, no, we are not getting that. D square y by dx square is, okay, let's put it that way. D square y by dx square is coming to be minus a square upon root over ax plus b and multiplied with ax plus b is this. So we have y is basically root over ax plus b. What is d square y by dx square? Let me simplify it for you. This is equal to minus a square upon root over ax plus b, right, into ax plus b. Yeah, and This becomes ax plus b to the power of 3 by 2. So it will be minus a square upon ax plus b into ax plus b. Okay. And we have plus dy by dx whole square. So dy by dx is this. We do whole square, we get a square by 4 ax plus b. 4 times of ax plus b. Alright, so this cancels. We have minus a square upon ax plus b plus a square upon, oh, we have done somewhere wrong. 2, oh, this, my bad. This 2 is not here. It will be in the denominator, right? So this will not get cancelled. It will be 1 by 4. Yeah, now we are getting right answer. 4 times of ax plus b. This is also 4 times of ax plus b. As you can see, this term and this term cancels. Your answer is 0. Okay. So first of all, find out dy by dx. Then you find out d square y by dx square. Then you put it in this equation on the left hand side, get it equal to the right hand side, and you can show, hence prove, that's the answer. Okay, next question. Y is log of sine e to the power x dy by dx. Very easy. You just have to find out the first order derivative. So, dy by dx is differentiation of log of sine of e to the power x. What we will apply here? Chain rule. Chain rule is basically differentiate log x, differentiate sin x, and differentiate e to the power x, right? So log x differentiation is 1 upon x, sin e to the power x. Sin x differentiation is cos x, cos e to the power x. E to the power x differentiation is e to the power x. Now what is cos upon sin? Quickly tell me. What is cos divided by sin? So this is cos e to the power x divided by sin e to the power x into e to the power x. What is cos upon sin? Cot. So my right answer is cot e to the power x. Now this question will come only for 2 marks. It is very easy. Okay. Not more than that. You just have to find out the first order derivative. Clear? Okay. Last question of the day. This was asked in CBSE board exam. Find dy by dx if x is given in terms of t and y also given in terms of t. Parametric form. Simple. So dy by dt is differentiation of 2at. What is differentiation of 2at? 2a. Dx by dt is differentiation of at square. At square. It will be 2at, right? Now divide it. When you divide it, dt cancels, 2a cancel. Dy by dx is basically 1 upon t. That's your answer. Simple. Alright guys, so we have finally completed the chapter of continuity and differentiability. Today we have learned about finding derivatives of functions which are in parametric form, that is written in terms of some other variable, and second order derivative, that is d square y by dx square. Alright, here is the mind map for you to remember how do we find out the second order derivative of any function. And what is parametric form? When one function, when both the variables are written in terms of some third variable, then how to find out their derivatives, right? So with this mind map, you can easily revise the 2 topics in just 2 pages itself before your exams. Alright guys, so congratulations, chapter number 5 completed with all the practice of important questions as well. Now if you want notes of this chapter, quickly join our Telegram channel. We are sending you notes every day over there Also, we'll provide you with all the notifications of classes, important assignments, and everything else. That's like after class, only communication possible between us is through Telegram. So do subscribe it. Okay, so if you enjoyed today's lecture and understood everything, quickly subscribe to Vedantu Malayalam channel where you will get physics, chemistry, maths, biology lectures for +1 and +2 along with your NEET, JEE, KEAM preparation and much more. Okay, and do hit the like button if you enjoyed today's session. Thank you so much for watching. Share it with your friends, bring them also on the channel. We'll have lots of fun together. Okay, have a great day, guys. See you all in the next class. Tomorrow, let's have a week quiz. What say? Let's have a week quiz on rational relations and functions and continuity and differentiability because we have already completed these 2 chapters. Alright, thank you for watching. See you all in the next class. Bye bye. Take care. Bye, guys.